请启充话筒。
啊，挺凶的，满足死，找了一桌人，找了一桌人，川旅，谁啊？Okay, I think let's start first. Let's recall the idea we have gone through, which is limit. The limit of a two variable function of two variable equals some set. And then this set is in R. Okay, so where does this graph live in? This graph live in where? 哎，早上还没有起来呀。This graph live in where? R? R3. How do you construct R3 here? Where do you get the number 3? You add the domain and codomain together. Okay, here you add the domain and codomain together. Right, so let's take an example here. So for example, the hemisphere. Okay, so let's say this is our fxy. So where should my domain be? Okay, so let's define our domain like this. So here is the domain. So let's draw like this. Okay, so here's my domain here. So let's call this D. Okay, so what's the idea of limit here? The idea of limit here is, let's say we take a point in the domain, call it AB, okay? And I look at any path in my domain to reach AB here, okay? So I want to look at what happens around the point, uh, I mean, around the point for this path here. So let's apply F. Okay, let's call this gamma. Okay, let's look at what happened to F gamma here. Okay, so to see what F gamma be, you need to know exactly what this F is. Okay, so what's this F? Can we give an explicit F or not? Let's say this is what? X minus 2 squared plus minus 2 squared. Okay, can you verify that this will give you the hemisphere? No? Can you verify this? You know how to verify? You know how to verify? Still remember? Yeah, let me move this a bit. So what's the natural domain for this function here? This is the square root function, right? So you want to make sure that the square root is greater or equals to 0. We need extra things here. So, I mean, what's this domain? So x squared squared has to be greater or equal to 0. This means what? No condition here. I think we do. I think let's wait, anyone still remember the function that give hemisphere or not? Forgot. Okay. Huh? So one minus? Oh, minus. L square, L square. Was it L square? Yeah. Yeah, 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 yeah. 放在哪里？最前面 You mean put here? Like wait, put here something like here. R square, huh? You mean like this, huh? Is it? Okay, let's check this. So if I put a square, r square here, what do we get? We get 4 is less than or equals to x square. X minus 2 square plus 1 minus 2 square. Okay. But what does give you? What does this give you here? You know? Can you recognize that this is a circle equation here? Okay. But we also take all the value which is less than 4. Okay, so meaning we take the whole or all this here with center what? What's the center? The center is okay, maybe use another. The center is 2, 2 with radius 2. And then why you have this height here, you need to check what's your range of your f. What's your range of your f? Still remember how to check your range of your f? What's the technique to check the range of f? So you have the condition on what happening inside the square root here. So, so let's see. The range of f is what? On one side, you have fxy equals to this greater than 0, greater or equal to 0, right? Because because uh, uh, because everything inside the square root is greater or equal to 0, so let me something useful here. It's greater or equal to square root 0, which is 0. Okay, but how about the other side? How about the other side? Is it bounded above by something? Do you remember? But what's inside the square root here? 4 minus positive number. So, so is it bounded above by something? Bounded above by what? Okay, the thing inside square root is bounded above by 4. Okay, but after taking square root, it is 2. Okay, so it's bounded above by square root 4, which is 2. Okay, so that's why you have this height here. Let's say we want to lift this hemisphere a bit. Okay, we lift it from the xy axis here. So let's lift it. Let's change our f here. Let's change our f. So I want to add the height here. So here is my height. So I want to add, for example, let's say add another 2 here. Okay, so we'll add extra 2 here outside this square root. So to be precise, I want to do this. And just to shift the hemisphere up. Okay. Then my range will change. So I need to add 2 to all of them. Okay, so you can see that this hemisphere is lifted up by 2. Right, so with this f here, okay, you can apply f on this point and then look at how this f changes on this sphere here. So for example, maybe go like this. Should be going to top. Okay, so let's say this point is called the limit of what's this limit? Limit of x going to limit of xy going to AB of fxy. Okay. 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 So you can take different path in your domain, and then you look at what happened on the surface. Does it make sense? Okay. So this is what it means by this limit of fx here, fxy. Okay. So if you have a path in the domain, you also have a path in the codomain. I mean, you can plug it out in the graph. Okay. Any question so far about this limit here? So you see, about finding this domain range will help you determine the shape pretty much. Okay. Whether why it curved like this, we can use a partial derivative to explain it. Okay, but with this domain and the range, you will know roughly what point can be hit by this function here. Make sense? Okay, yeah. But why the shape is like this, we can use a partial derivative to like construct it. Remember or not, in the assignment, we use horizontal tangent, vertical tangent to see how the curve around. Okay, similar here. Later we use a partial derivative. Another reason why this is a hemisphere, you should recognize that if you square that fxy, it satisfies a sphere equation, right? Sphere equation is what? X squared plus y squared plus z squared equals to something. Okay. Okay, right. So let's continue with the limit business. So next thing we'll define continuity here. Okay, what's continuity? So there are three things you need to remember. One is to say that fxy is continuous at the point AB, f must have value at AB. So you can evaluate f at AB. Second, f also has a limit at AB. So you can take a path and then look at what is the limit of f. Third is the most important thing. These two numbers must agree. Okay, these two numbers must agree. The limit must agree at the value that f take at AB. Okay. So in short here, we will write lim of xy to AB of fxy is f. Okay. So if I close these three conditions, I just give you this. Can you read the three conditions out on? I think so. Cannot. First two is what? Tell me the first two. Okay, you see, on the right hand side, FAB means there's a value already. Must have a limit, so our left hand side tells you there's a limit. The condition. You see, you specify the left hand side, you specify the right hand side. There's one more sign you haven't specified, right? So what that sign tells you? That true value must agree. So this definition already include that three signs. Okay, this is how you should read this mathematical equation. And to be able to write FAB, you mean you can compute it already. There's a value there. To write this limit down, it means this limit also exists. You can compute already. Then these two numbers a priori, right? They wouldn't be the same. They might not be the same. Right or not? I give you an example. One example you should keep in your mind is this example here. The very easy calculus one example. So if you have left right limit, right, converge to this point here. It doesn't necessarily equals to the value that taken on this point. Not necessarily. Okay. But if it equals, then we will say that it is continuous. Okay or not? So this makes sense to like what you think about continuity, right? You draw the function without lifting the pen. If there's a hole, then you need to take away your pen first. Does it make sense? So this also works for two-dimensional function of two variables. Okay. Is it clear? Okay. Right. So let's give some example here. So let's give some example here. So we have discussed some very continuous function. So for example, polynomial, a continuous function, exponential function, a continuous function, right? And then trigo function also continuous, right? And for example, the rational function. Okay, rational function means what? you have a polynomial divided by the other polynomial. Okay, so rational number, right? Rational number take a number divided by another. But when we talk about rational polynomials, you take one polynomial divided by the other polynomials. Because there's a division there, right? So make sure that the points are defined. Okay, only you talk about continuity. So if it is defined. Non-example here will be what I draw just now. So you have a limit to a point, but FAB is somewhere else. Let's split. Okay. Okay. So you can see that. Let me write here. So lim of fxy is not equals to FAB. Okay. So here it's FAB. Cannot. 有想法吗？要问吗？有想法吗？In my class, I value an idea very much because this idea is the idea that can give you think. You will think in your way. Okay, so I can help you to shape your path. So please ask if you have any bizarre idea, maybe not normal one. Okay, if you don't have idea, you also have to at least understand my idea. Okay, so there are two things happening inside this class. One is your idea, one is my idea. So these two have to clash, create new knowledge. Okay. Any question? 有问题吗？还是你有什么例子你不确定想问的？ Okay. 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 So another property about a continuous function is composite function of continuous function is continuous. So this is a very nice theorem to remember here. Okay, we won't prove it. If you would like, you can prove it yourself. But composite. Okay, let me write down the sentence for this theorem here. So this theorem pretty much say that composite of continuous function is continuous. Okay, so like practice reading again. I practice reading again. So if you try and read the theorem first, you will deduce this line or not. You know how to go from English, from mathematics statement here. If a function g or two variable is continuous at AB and f is also continuous at GAB, then the composite function f composite g defined by the following f of gxy is continuous at A. Do you feel any weird or not reading this? Sorry, Kim Xiao, I give input. Anything weird or not? Why not f is on AB also? Why at GAB? Sure. Oh, good. Right. So you see that f is actually a one variable function. Good. Okay. So I mean, do you know where their domain is? You know where their domain is? So G, so first of all, G is going from R2 to R. F going from R to R. Okay, so only then you can compose them together. Correct or not? You first do G and then you then do F. Okay, so the composite should go from where to where in the end? the composite function from R2 to another function of two variables. Okay or not? Okay, so you have AB going to GAB and then going to f of GAB. Okay, that's what that's why we define the composite function on R2 by this. Okay, it's a natural thing to do. Okay, it's a natural thing to do. Okay, so the composite is a function of two variables. Does it make sense? So how to do the two variable things? So the obvious thing to do is just apply f on that value g. Okay, so this is a natural thing to do. But one big result is the function you defined just now is still continuous. Still continuous. Okay, if the previous two are continuous. Okay. But to prove this, it's not too hard. Just a bit tedious. Okay, so let's use this. So the question was where does the following function continuous? Okay, let's look at A. So this is a rational polynomial, okay, because you have a polynomial divided by the other polynomial. Does this function define anywhere or not? Does it define anywhere? In particular, does it define on the origin or not? Why not? Why not define on the origin? You won't. You won't. Because the denominator is 0. Okay, so this is only defined when where? Which point we should throw away? Which point? Open. Good. Okay, so we need to make sure that y cannot be equal to 4x squared. Okay, on that line, the denominator is 0. Okay, because y minus 4x squared is 0. Okay, so what's this line here? So let's try and plot this line. Try and plot the domain first. Okay, so let's plot the domain. So what's the line that we throw away? So we throw away y equals to 4x squared. Throw away y equals to okay. So this is a line y equals to 4x squared. Okay, so away from this parabola here, you will have a surface at the top. Okay. So when is it continuous? What do you think? Where is it continuous? Is it continuous on the whole R2 or not? On the whole domain? Huh? It's continuous on the whole domain. Okay, because this is just rational function. So just now I give example, right? If it is defined on the point, it should be continuous. Okay, so fxy is continuous basically on all its natural domain here, except the parabola. So why except the parabola? Still remember what's the three rules we need to make sure the continuity of f? Which rule it violates on this parabola? Which rule it violates? So which of these three rules it violates if we check on this parabola? 1, 2, 3, which one? first, second, or third? Third, do you have first or not? What happened at the denominator? It is 0, right? So it cannot really compute f at those points. Okay, so we don't even have 1 already. Obviously, we don't have 3, but we already don't have 1. Okay, unless what? Unless you define piecewise on this curve here. Unless you do that. Yeah, otherwise we don't have point defined on those. On this parabola. Okay, unless you define piecewise. Do you understand what it means by define piecewise or not? You understand? What does it mean? Yeah. So on this point, we need to specify again what point I should take. Okay. Because obviously this cannot compute for the point y equals to f for x squared already. So you need to define another value of this. Okay, so 1 we already not satisfied, so it won't happen at continuity won't happen at y not equals to 4x. I mean, yeah, 4 equal to x squared. Sorry, y equals to 4x squared. Right, how about this one? Where does this function continuous? And this is a function of what? This is a function of what? 回答吧，想到什么我就function of what 咯，看你怎么回答。What function is this? 解释就解释吧，我没有要一个答案，你可能要讲一大堆东西。我说 Okay. Okay. So why is it a continuous function inside? Okay. So why is it everything inside is continuous? Not rational. Can be more simple, right? It's just a polynomial. Okay, it's just a polynomial. Okay. So polynomial is continuous everywhere. Okay. And then cosine is also continuous everywhere. Okay. So by the theorem above, composite function is continuous. Fxy is continuous at all R2. Okay, since what? Since x cubed minus 4xy plus y squared is a polynomial function that's continuous on R2, is a polynomial that is which is continuous on R2, and cos of z is a trigonometric function which is again continuous on R. Okay or not? Okay, so as a composite, it is continuous on the first domain. Any question so far? Is it clear? 有问题吗？还是你想到可能有问题，什么问题没有考虑到，可以问的。因为有些东西可能我会藏起来慢一点问你，如果你提前把它问掉，就你把它发现到。有问题？Okay. Clear. How to check continuity? Okay. Okay. Right. If don't have problem, we will jump to derivative. We're done with continuity now. 没问题吗？小朋友有问题吗？没问题。OK。Feel free to ask 啊，不要不好意思啊。OK，未来要不要再做一个嘞？how about do this? This one is the example that I mentioned. Unless you define piecewise. Okay, I let you do this. Let you give you 2 minutes. Try this. If you recognize, actually, this is a computation that we did last lecture. Yeah. 3x squared y over x plus. Okay, so this function is a function from where to where? 来回答一下，有没有人在听课？Function from where to where? Good. Okay, so meaning when you want to discuss continuity, right, you need to discuss on all the points that the f defined on R2. Okay, so in this case here, any point get left out or not? What's the natural domain of this f? For the first part, xy cannot be equal to 0. Okay, if xy cannot be equal to the origin, does this function define or not? You can compute a valid finite value, right? If you fix x and y, not 0. Okay, but why they split like this? If you substitute 0, 0 into this rational polynomial here, what do you get? 来，快点，反应慢点。Max error. Why max error? You get 0 over 0. Okay, so that's why we need to define it piecewise. Okay, 我要另外告诉你这个零零的点是什么东西。Okay, then now we want to check for continuity. So what's the domain you need to check for continuity now? You need to check for everything inside your domain, which is R2. Okay, so I claim that the point when not equal to xy is easy to say. It is continuous. Why? Because it is a rational polynomial. Okay, it's continuous whenever it is defined. Okay, so the only non-trivial, that one you need to take for granted because I take it for examples. Otherwise, you need to use the epsilon delta to show it. Okay, so you need to take it for granted for that one. So the other non-trivial thing to say is about the point 0, 0. Is it continuous there or not? So if you want to show continuity at 0, 0, what's the 3 things that you need to measure? 3 things. Right? F00 defined. So is F00 defined in this case? Which is 0. Good. Second, you need to compute the limit to this 0, 0. Okay, so let's compute it. And I claim that we computed this in the last lecture. Do you know how we computed it? Do you remember or not? How do we compute this guy here? Okay, one of them we use squeeze. Okay, the other we can use uh, polar coordinate. Okay, yeah, you can use squeeze. You also can use polar coordinate. So if we use polar coordinate, what do we get? Okay, test you again, revision. This one got the test polar coordinate. Polar coordinate, what do you need to remember? How to go from xy to polar coordinate? What's the main three equation you need? Hey, why you guys always remember this one as the first one? Because this is a consequence of setting x equals to r cos theta and y equals to r sin theta. This is the main thing to go from from xy to polar, you know, because you want to construct the circle, okay? And then this, only then this r square equals to s square plus y square is the result. Okay? Well, I mean, if you want to say morally, r squared equals to s squared plus y squared is also true. Because why? Because we say that we want to know, okay, we want to know for every point in xy which circle it lies on. Okay. But if you just write out r squared equals to s squared plus y squared, it's hard to see this r cos theta and r sin theta. Okay, because why? Because you need to remember that the trivial identity. Cos squared theta plus sin squared theta equals to. So if you just remember one, then you will easily forget theta. Cos squared theta equals plus sin squared theta equals to 1. On the left hand side got theta, on the right hand side no more theta. So the 1 will like obscure your theta. Then you kind of forget it. So please remember these two. These two is very important. From these two, you can deduce the third one. Okay, but from the third one, it's kind of hard to see where this theta comes from. Sure. Yeah. That's why I draw this up. But yeah. Yeah. Yeah, yeah, sure. I mean, sure. Just that I want them to like easier to memorize, to remember. Okay. Yeah. Okay. Right. So x squared is what? R squared cos theta r sin theta over r squared. But what's this limit here? So this function contains an extra r there. And you treat cos theta and sin theta as a constant function of r, so this guy will go to 0. Okay, so in this case here, this limit here is exactly equal to f 0. Okay, so it satisfies the three conditions of continuity. So f is continuous at 0. Okay, also f is continuous at xy not equals to 0 because because it is a rational polynomial there. Again, rational polynomial. Okay. Okay. Is it clear? Okay, no. Yeah. Any questions so far? Cosine x not pen u equals square. Okay, thank you. Yeah. Please take note. I might frequently have a computational error here. Okay. Okay, thank you. 对，你们要做一个勇于指出错误的一个群体来，好不好？可能你在外面会被晋升啊，是吧？不是晋升， But 在这个课里面你要练习一下。OK OK. Before we take a break, I want to talk about an idea of a derivative, and then we will break for a while. So, what's the idea of derivative? So, I want to go back to the first principle of derivative. Every time when we discuss a similar idea in calculus 1, I will start with calculus 1 picture because it's easier to draw and easier to describe there. And then we can just generalize it. So let's start from derivative of one variable. Okay, so if all of you are familiar with this definition here? Okay, yeah. Okay. So it's the limit of this whole thing here. You know, there's a name for this thing. This is called a secant. Okay. This is called a secant. So it's a gradient of the line of the tangent line at x. So what's this secant doing? So let's give f here. I think you want to listen carefully because this is the idea of derivative. Otherwise, you'll miss in higher dimensional case. Okay, so let's look at this point here. Okay, let's fix this point. So call it x. Okay, so where is s plus h in this case? Have any idea? Where's x plus h? Say h is positive first. So where's x plus h? On the right of x. Okay, around here. So x minus h will be on the side in this case. Okay, so let's say we take h greater than 0. So what is x plus h then? So you just read what is the value taken by x plus h under f. Okay, and then where is fx? So this is where the function that takes value. So what is f x plus h minus fx over h? Is the line that join this x fx and x plus h. X plus, right? Is the line that join x fx. So let me point here. So here is x fx and x plus h of f of x plus h. Okay. So what the business here? The business here is what? Taking the limit of h to 0. Meaning what? You need to consider all the points nearby x. And then do this secant business here. So what do you do here? So you will form a more secant. Okay, you will form more secant here. Wait, let me draw it properly. You will form more secant here. Okay. Can you see that if I take closer and closer, this sequence here will exactly lie on the tangent line on x. Can you see it? If you take the limit of this secant line here, it will converge to this tangent line on. Okay, so this is this limit business here. So if you want to find a derivative, instead you are looking for a limit of another function. What function is that? That's a secant function. Okay, so you look at how this secant line changes. Does it make sense? So this is the idea. This is the first principle of a derivative. Okay, so you're actually looking at the changes of this secant line or a secant function. Okay, still involving f, right? But it's a difference of f over the difference of x. Y1, Y2 over x1, x2. Okay? The changes in the f value over the changes in x. So the ratio. So what's this ratio? This ratio has geometric meaning here, which is the gradient of the secant line. Any question? So now, from now on, when you talk about function, please think about, when you talk about derivative of function, please think about it this way. Okay, limit of a secant line. You can see that the limit of this secant lines will converge to the tangent line. So actually, this limit is a random one, not just h greater than 0. So you can consider negative h. So meaning your h can jump around this x point. Okay. So if it jumps around, what does it mean? So let me draw a few more secant on the other side. Then we will talk about it. So if you're just purely going from left side, you also can see that the secant line will converge to the tangent line. But if you take random sequence, so maybe one blue, one red, one blue, one red, one blue, one red, one blue, one red, is still converging. Okay, if this tangent line exists, only then we will say that this point is differentiable. Okay, only that we will say that this point is differentiable. So did you remember a very classical example where a function is not differentiable? These examples are important for you to understand mathematics. Do you remember what function is not differentiable? Very easy one. What function? Huh? Anyone can remember or not? If you don't have this example in your mind, then max will be pretty hard for you. Non-differentiable function, one variable. Huh? Absolute? Absolute? X. So if you try and make this steeper, you'll see that it is actually not differentiable. Why? Can you use this method to explain why this function is not differentiable or not? Can you use this limit of secant method to explain why this is not differentiable? I'll let you think a bit. Why? Can you use the secant method to tell why this is not differentiable? Differentiable at where? Exactly at the origin. 0. Why? Can you use secant method to explain why? So what's the method I say? You start with 0, okay? And then you look at nearby 0 plus h, and then you form a secant line. Okay, you can see that on the right-hand side, no matter what sequence you form, you always get the same line. Okay, your secant on the right-hand side is the same line, which is like this. On the other side, if I take negative h, what happens? The secant I form is always what? What line is this actually? Can you tell what line is this? Y equals to minus x. Okay, on one side, you just get y equals to x. On the other side, you just get y equals to minus x. So it can converge or not? Can converge? It's always a different secant from left and right. But in this case, it's different now, you see. On the right side, it converges to a horizontal line. On the left-hand side, it also converges to a horizontal line. So that's why we call this line a tangent line at x. But here, on the right-hand side, you only get one kind of secant, which is y equals to x. On the other side, you always get y equals to minus x. So whenever you go to the 0, 0, the secant won't converge. Because these are the two lines. Can you recognize these are two lines? Okay. So they don't converge. So it's not differentiable. Okay? Any question? It's quite fascinating, you see. these two actually kind of the same shape, just that this one is very steep. Right or not? Actually, we call this a king. Okay, so there's a king. Yeah, okay. Okay, and then actually same shape, but different steepness. Okay. Any question?有想法吗？Actually，你如果看到这两个 example，你应该还有另外一个想法。Because this one is concave. Okay, I don't want to say concave. Huh? Concave outward. Yeah, concave outward. I mean, I make this gradient. How to say? Okay. I mean, from this two picture, right? Can you think of another example? You can think of this part that coming down. Instead of coming down, it can go up, for example. You get what I mean? So 有点 sorry 啊，用错字了，但是我想不到要用什么字。But let me draw it for you. So how about you consider this kind of case? 是鸟 Okay, still going downward, but how to say? Let me think. Let me think. Do you have any English word to describe? So okay, so I want to say that these two, first example and the third example, right, is a variant of a second example here. Can you see why is it a variant? Because one of them I make it 真的想不到什么字可以用，还是英文比较好，帮忙想一下。Why is this the first and the third in example is a variant of the second example? Variant 会听吗？一种变形variant. Okay. So what kind of variant is it? So the first one is you bulge downward. Okay. The second one is bulge upward. Okay. So also you can ask whether it is differentiate at this point or not. So to ask this, you also can form the secant around it. Right or not? You can form secant around it. Okay. You can form secant around it. So, okay, so let me draw it. And draw secants like this, like this, like this. Okay, on one side. On the other side, you also can draw it. Okay. Do they converge? Let me ask you, do they converge or not? Converge or not? If we go from outside into this point here, do they converge? Seems like converge. Converge to what? To a straight line. Seems converging, right? Converge to straight line. But you need to ask yourself, what's the gradient of this line? Infinity. But our limit won't take infinity. Okay, but our limit won't take infinity. So it's not differentiable also. Because our limit don't take infinity. Okay. Yeah. Yeah, last time I think we showed it for these kind of cases. Use the polar curve. I have a question. Not derivative, but not differentiable. That means tangent. We won't call it a tangent. We won't call it a tangent. Yeah. We define tangent line if the dy dx is non-zero. So we won't call it a tangent. So 这里有个差别在那边，虽然你看到那个 secant 是 convert to 一个线，但是我们不会叫它是 tangent。暂时没有名字。Maybe in some mathematics area, this kind of thing is useful, but not for now. Not for now. is still not differentiable. Okay, not differentiable, not differentiable because its gradient is infinity. Okay, so because we won't allow our limit to be infinity, we will say that limit diverge. Then, but geometrically, the secant really converges to some line, but it's not within the scope of this class. Okay or not? So next time, whenever we talk about derivative, try think about it as a secant line, and not just differentiate x squared equals to 2x. What does that mean? Okay, later we will say what does that mean. Okay. Yeah, let's break until 10:12.刚才一会有针，一会 休息到几点啊？忘记了，几分啊？刚才我讲12分，OK。啊，我行，对对。Oh my God. Thank you. That implies continuity difference. The difference Hello, testing. Okay. Another thing we need to kind of get to in our mind first is always you memorize, right? So if ready, ready, fx equals to x squared, you say that f prime x equals to 2x, right? So what does this really mean? What does this really mean? So again, you draw the picture first, okay? So in this class, drawing picture is one skill that you cannot miss, because later you'll draw more picture in a higher dimensional. So make sure you know how to draw low dimensional first. So let's draw this x squared. Okay, so what does this f prime x equals to 2x tells you? And x equals 0, what is this f prime here? F prime is 0, because you really see that the tangent line at the 0 is the horizontal line where the gradient is 0. But at f prime, let's say f prime 1, which is 2. So meaning the gradient, the tangent line of this gradient here is 2. Okay, so for example, like this. And then you can imagine that when the x grow, right, the gradient will grow steeper. Correct or not? So let's say m1 is 0, m2 should be 2, m3 here will become 4. Okay, so meaning what? If you look at the changes of this gradient line, it changes linearly. Linearly depend on x. Okay, linearly. Okay or not? Does it make sense? Okay. If you differentiate 2x again, you get a constant. So meaning what? The linear function, the gradient for the linear function. Okay, let's draw again. So yeah, let's draw these f prime x out. So if you do derivative, you will see that the function changes linearly. So linearly how? So like this. Okay. So if I plot f prime x here, this is f prime x equals to 2x. But if I want to look at the gradient, the derivative on this linear line, let's say at 0, 0 here. You can see that no matter what nearby secant I form, it is the same line. You see or not? If I take a nearby point around 0, okay, let's say 0 plus h here, and then I form the secant line also, is the same line. Okay, no matter what h you take, it's the same line. No matter how you approach from the left and right, it's still the same line. Okay, this is not just true for this point out. If you move to x equal to 1, 2, 3, 4, it's still the same story. Can see or not? It's still the same story because it's just a straight line. It's exactly the secant line. Meaning what? So meaning what? The gradient doesn't change at any point. It doesn't change at any point. Correct or not? If you differentiate this, what you get? Constant 2 function. Okay, so the gradient doesn't change. Okay, because if you differentiate 2x again, you only get 2, which is a constant function. At every point, you have the same gradient. Why? you can see from the secant definition. Okay or not? Does it make sense? Okay. No matter which point you pick, you form the secant around it, is the exact same line you get from this graph here. It's the same line. And you can see that the gradient doesn't change at any point. So that's why you differentiate again 2x, you get 2. Okay, so it's a constant function. Does it make sense? Understand or not? Okay, later we'll see more example, but please keep these in mind. Any question? Any question? No? Okay. So please bear in mind, if you differentiate a function, you get another function. What's that function? This is a function of your gradient. Okay, so this is a function of your gradient. Function of gradients. Okay, so meaning x squared have a linear function of gradient. So your gradient increase linearly. Increase, when we talk about increase here, because we have order on R. You know that we have a natural order on R? 一个天然的排法我们 R 从小到大。And so this is a natural order we refer to. From small to negative to positive. Okay, so this is the natural order that we consider. Any question so far? If not, we will go into two-dimensional now. Okay. So let's go into two-dimensional. So even we want to discuss about two-dimensional, we still you start with one-dimensional first. Okay, so what do we do? What do I mean by that? So first of all, let's start with a function of two variables here, x and y. Okay, and then we keep y constant first. Okay, let's keep y constant. Let's say y equals to b. Then you can see that f(a)(xb) is a function of a single variable x. So let me give you an example here. So for example, fxy equals to x plus y. Okay, so if we set y equals to b, so what does it mean by set y equals to b? 因为对你来说，好像 y 跟 b 好像没有什么差别这样的，是不是？ But b here means a real number. So for example, take a real number. Let's say take 2. Did you notice that fx2 is equal to x plus 2? So it's a one variable function already. So this is what it means by this line here. If y is held constant, y equals to b, then fxb is a function of a single variable. Okay? Because the other variable are already substituted. Okay, in a non-standard word, we substitute it. Okay, after we do this, doing this, it becomes a calculus one function, right? So we can do derivative. Okay, so we can do the same derivative as what you do in calculus one. Okay, because you can see the limit here is just a secant of one variable. Okay, if we substitute y as constant, and then this is what we call, if we substitute y as constant, then this derivative is a derivative with respect to x direction. Okay, we call it a partial derivative of f with respect to x. Okay, just partial, because we still have the y part. Now we just do the x part. Okay, yeah. So the same story is I can keep x constant and then I do derivative on y. Okay, so there are two partial derivatives here. Okay, one is with respect to x, one is with respect to y. So with respect to x means I make x a variable and then keep y constant. And if I do with respect to y, differentiate with respect to y, so meaning y has to change, but I keep x constant. Question? Maybe you want to ask what is AB here. So this AB here is like what we do just now. We fix a point. We ask whether that point is differentiable. Okay, so we ask at this point, what is the partial derivative with respect to x? What's the partial derivative with respect to y? Later, we will tell how to speak of fxy to be differentiable in terms of this key partial derivative. Okay? So we break the question down to one-dimensional now. Later, we will answer a two-dimensional question. Yeah, so we first learn these one-dimensional two. Okay. So similarly, like just now, we can make our derivative as a function. Okay. We know how to compute f prime 0, f prime 1, f prime 2, f prime 3, but we can collect all of them and make it a function. So what's the difference here? Maybe to you, a, b and x, y 没有差，是不是？有差吗？反正都是一堆字母嘛。很多人讲学数学，写到后面只学字母了。把你现在是学数学哦，这是你的专业哦，你一定要学懂它是什么东西。OK，either you like it or not, you have to know it。什么差别啊？这个 A、B 和 S1。A、B 和 S1 什么差别？A、B is already a fixed point, so you need to learn this language. Whenever we say fix, the point get fixed 是什么意思？丙兄知道吗？什么意思啊？每次我们讲 point 被 fix 好不好？在那个点啊，没有错，但是不够准确。啊，差不多了，还差一点点，还差一点点，还差一点点，还差一点点。还有一个动作很重要 ，fix 的这个动作就是这个英文字，我们叫做 fix， 选定哪个点。So for example, for example, the top here, if we let AB, let's say, equals to 1, 1, then this is a derivative at 1, 1 only. Okay, blah, blah, blah. I don't want to write now. Okay, maybe write it down is better because I will show you what happened. So fx 1, 1 is what? Limit of h go to 0 of 1 plus h, comma 1 minus f11 over h. Okay, so you can see that most of the point already get fixed already. Only that h is changing. Okay, that h actually we call it a bound variable. There are two kinds of variable. One is free variable, one is bound variable. Okay, that h is bounded. F is free because we can put any f into it. Okay, f is free. But h is bounded. Why? Because we have a condition on h. H must go to 0. And then the bottom here, what? Here is apply to all xy that makes sense. Okay, apply to all xy. Okay or not? 明白吗? Okay, if you want to have an example in your mind, you sure, of course, mathematician, you must have examples in your mind. So what's the example in your mind? Is this example? So how do you differentiate a point where get fixed and not fixed? So this one is as a function. Okay, so here, this f prime x is as a function. But if you want to fix point, what do you mean by that? Meaning you have f prime 0 is what? F prime 1 is what? For example, okay? So if you collect all these numbers together, you will form a function. Okay? Not always true, it's not always true. It's not always true that if you have a function from a domain to a codomain, you can write it like that easily. No, it's not true. It's just that normally what we deal at now is easy to write the formula down. It's not true that whenever you have this process, you have a function. In real life problem, not always whenever you have a map between two things, you can write down a function. But what we can do was we use approximation. We use function that can be written down as formula to approximate the real life problem. Right? This is what happened in real life. So whatever we learn here is just basic only. It's those functions that I can write down a nice formula for it. But it's not always true we can do that. Not always true. in particular in real life, it's not true. So you need to learn further knowledge about approximation. For example, you need to approximate the real life function using the linear function, for example, using exponential function, logarithm function, trigonometric function, and so on. Okay. Does it make sense? 明白吗？你知道这个 approximate 的概念吗？ You know? You know what approximation means? 这样子，不确定，说说看你的意见，说不定。不止类似，而且 when you take limit 啊 you have to approach to the real problem. Okay, for example, a very easy case 啊 cosine sine 啊，它的 curve 就这样吧，很稳定的。你会觉得它是说像波浪 ，for example， 波浪，有去过海边吗？这里有去过海边吗？谁没有去过？啊，要去一下，那你可能你从海岛来的。说，如果你没有去过马来西亚很多海边，去一去，看一看那个波浪。Cosine sine is a perfectly good wave pattern, but real life 不是这样的，它可能会大一下、小一下、大一下、小一下、大一下、小一下，或者它 period 会忽然间变一下。为什么？为什么会有这种事情发生？为什么？啊，现在我讨论 real life 哦，为什么？为什么有这种事情发生？为什么有时候它会大一下、小一下？不止啊，它 period 可能会很紧张一下，然后又放慢一下。这些东西会同时发生，你知道吗？为什么？什么外界因素？一个是风，还有什么？哦，月球潮汐力，先不要去这样远先，还有更近的东西，鱼，可能它本来游的顺顺的，忽然间它猎物来了，明白吗？忽然间它猎物来了，它冲了哦，连波浪本来是这样的，被它影响哦。So how do you take into these criteria into your consideration？这些是很 random 的 variable， so you need to think about it. How to quantify this variable into your real life problem？ OK， 说这些是非常重要，非常需要想了，这是真的需要想了，没有人想到。但是 OK，how to systematically include these things? Okay, so what we learn is only very basic only, very basic function. Okay, so this is partial derivative as function, and then some notation for partial derivative. So 不要吓到，如果你看到这些有的没有的东西，因为它们都是一样的东西。Okay, so what are the same? So you can write f sub 3x, or you can write partial f partial x. So if you put in your plain text, this one is slash del, okay, slash del partial over partial x, and then also sometimes we call it partial z over partial x because we set fxy equals to z, and then sometimes we put capital D, and then for d1 dx. Why 1 and 2? Because we make x as our first axis and then y as our second. Okay, so this one is by convention. Okay, we won't swap one. Remember why we won't swap? Because this is the positive orientation we pick. Okay, we start with y and then go to x. Anti-clockwise. And then three-dimensional x, y, z, because the positive orientation we pick was right hand root group. So x, y. So these are just notation. If you see these, don't confuse. Right. So now, how to compute? Okay, how to compute a partial derivative here. So let's start with this function fxy equals to x squared y plus dy cubed. So just now I show you the limit function, right? So in this class, almost we won't go for the first method to compute it. So we're gonna learn a technique to compute it. So what to do here? So let's say we want to compute f with respect to x. at 1, 2. Let's compute what is fxxy first. Okay. So what do? You keep y direction constant. So meaning you see y as a constant function in x. So you just do derivative on x. Okay, so you treat y as a constant. So in this case here, y is constant, 3y cubed is constant in x. So you differentiate, what do you get? For the first term, you will get 2xy plus 1. What do you think? 0, because 3y cubed is a constant in x. Okay, so you get just 2xy. Okay, and then fy, xy, ne? You want to vary in y, so you keep x constant. So there's one term with x only, so x squared y is a linear term. So if you differentiate it, you get x squared plus 9y squared. So if you evaluate at 1, 2, what do you get? For the first one, you get 4. For the second one, you get 37. Okay. Well, I mean, I can challenge you, try the limit computation here. Maybe see if we can do it together. I think it's not too hard. So uh, let's do this. For example, what's this definition? I still remember or not? We take limit of h equal to 0. I'm not proving to you, but I just want to show you why we can do this. So if we take limit h to 0 of fx plus h y minus fxy over h. What is this? So actually all these value you know. You know how to compute them? You just start x plus h and y to your new function here. So if you sub all these together into it, what do you get? Get x plus h squared times y plus 3y squared minus s squared y minus 3y cubed over h. Okay, so if you expand everything, what did you get? What do you get? Lim of h to 0 of x squared y plus e plus what? 2hy plus h squared y. So you use the binomial expansion over h. So what do you get? You get 2y plus hy, which is what? We learned this in the last chapter, right? So what's this? 少了一个东西，少了 x Okay, thank you. 少了一个 x. So what do we get? So first 2xy doesn't have h, right? Okay, but the second part has h. Or we just left with which is 2xy. So agree with what we calculated. Okay or not? Yeah. So this is actually how you get differentiate polynomial. You bring the power down and then the power minus 1. Because this is what you did in the limit. We just found the pattern and then teach the high school students. Oh, if you see a polynomial, power down, power minus 1. That's a formula. But how we computed it is using this way. So using this way, you should see how these 2x pops up, 2xy pops up. Okay, how these pop up is actually by the expansion. Okay, by the power expansion. Okay, so continue. Okay, continue. Then I will give you maybe 2 minutes to try and compute this. Later we'll try answer together to see if you understand the concept. Actually, there's another thing to share. So 刚才不是说怎样为什么那个波浪有时候忽然间大就小，然后忽然间可能它 period 变短或者变慢，这个其实就是其中一个方法。那个渔夫去看哪里有鱼，他看到那里的波浪不规则，他可能可以推断出哦那边可能有一大群的鱼，或者那边就没有鱼，可能有鲨鱼，他就不用去了咯。明白吗？So I mean, although they cannot write down mathematically 为什么会对，但是这个是他们的 life experience。所以其实我们做数学的哦，应该要去多一点 experience 这些 life experience，这样你才会让这些 mathematical equation 啊 make more sense to 你自己。OK，很多人会说数学什么很抽象啊，为什么？因为他们在过他们的生活的时候啊，没有那么仔细，其实他们没有很注意周遭发生的事情，所以他们解释不出为什么我旁边会发生这些事情，或者有些人根本就不 care 为什么他旁边会发生这样的事情。但我要问你一句，你 care 吗？你会想说，哎，为什么这个鸟事今天会发生在我身上？For example，这种问题。当你在一问这种问题的时候啊，你就开始有发生逻辑链条了。不是因为我走太快，所以我跌倒，还是我没有到那个路的标志很滑，我跌倒。For example，这些在问问题、回答问题原因，这个就是逻辑来的，就开始封逻辑了。但是很多人是很 careless，就是他们没有这么关心。这样的话你学数学就很难，因为我们数学就是一直要问为什么、为什么、为什么。如果你是不问为什么的人，你就很难。说，I mean，这个应该是其中一个数学和算术差很大的地方。我不是要算吧，我要知道为什么这样算，哎，你才会知道为什么你被要求这么算，被要求这么算。如果你去看那个如果你知道股票的话，你去看股票，他们有很多 indicator 的，就是有很多个 index，不同的算法，各种除，为什么这些都有用？因为当那些人问一个问题罢了，就一个 basic 问题，这股票什么时候升？这股票什么时候下？可能100个 PhD TC 写出来，哎，看这个 index，看这个 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 index，那就100个 index 出现在你的，但是每一个都准吗？不一定，可能在某种情况下这个 index 有用，在某种情况下那个 index。Does it make sense? Yeah. Yeah. Okay. Right. So 算好这些东西啊，Let's check what's your solution 啊？If you differentiate with respect to x, what's your solution？有人算了吗？来，快点讲答案。没有人一个人算了。2x sin xy square plus s square y square cosine xy square. Okay, please check if there's something wrong please ask. How about with respect to y? To y, s cubed cos x. Okay, good. So basically, you use product rule, right? And some chain rule. Okay? Product rule and chain rule. I have to compute it. Right. Okay, let's continue. So, well, I started to teach you that derivative will correspond to some tangent line. So in this case here, this fx, fy correspond to what kind of tangent line? Okay, what kind of tangent line? So if you started with your surface here, okay, so at this point, what does it mean by the derivative fx here? So it means that if you take the plane, okay, with respect to x direction, and then you intersect your surface, you will get a tangent line here. Okay, you can take a tangent line on this curve here. Okay, so this tangent line has a gradient f, do you f? Yeah, fx. And then how about fy? You look at this point and then look at the gradient of the curve here. So how to obtain this curve? You use zy plane and then intersect the surface at the point AB0, for example. ABC or AB0? Oh, ABC, yeah, ABC. Okay, you trace a curve here and then you draw the tangent line. So this line will has a gradient F1. Okay or not? Okay. Yeah. Any question or not? You know how to read this picture here? So you start with a graph of fxy, and then you take either zx plane or zy plane to intersect your curve. 对吗？如果你拿两个 plane intersect，你会得到什么东西？拿两个 plane intersect 会得到什么？啊？拿到什么？一条线。Okay, so maybe you will get a line. So let me draw it. Okay, maybe you get this line here, intersection here. Intersection of two plane could be empty also. Intersection of two plane could be empty also. Yeah, parallel. Okay, will be empty. So it's parallel, it's empty. So it's like the line up. It's the same thing as line. So line, if it's parallel, there's no intersection also. But if line intersect, what could happen? If two lines intersect, what do you get? Either one point, or actually you can get the whole line, right? If they are the same line. Okay, so you can see that if it is a non-trivial intersection, the dimension will decrease actually. If you intersect two lines non-trivially, you get 1 point. Here, you get a line. So you see the intersection go down in dimension. 懂讲什么意思吗？丙真头讲什么？不懂，哪一句话不懂？上一句是什么？重复一下。喂，莲花都听不懂，那可能会明白。要记住我讲的话才可以问。OK。So what I want to say is a non-trivial intersection, okay, of surface of let me think how to say it. Okay, so the intersection of two planes, okay, non-trivial intersection of two planes is a line which is a one-dimensional lower than the plane. Yeah. 不考虑，我说 non-trivial。OK。I mean，通常我们如果两个都一样的话，这个就我们觉得蛮 trivial 的。就是如果两个一样的东西交合，肯定就一样嘛，就没有什么 特别，不特别的是这个东西，他们不一样，但是他们 intersect。然后我的 claim 是这种 intersection 是 go down in dimension，所以意思说它的 dimension 是比原来的 dimension 低，这是我的 claim。听清没？不要紧，不懂也 OK 了，不懂也 OK。懂了，你看讲一讲看懂了。也是像用用你自己的文字，引用你原始也可以，我们放出。对对，两个 surface 交叉，对对。For example, if you take two lines intersect non-trivially, same line 就没有什么好讨论啦，一样的东西 intersect 就是它自己。But 如果它不一样的 line intersect 的话，你会得到什么？一个点，点就是 zero dimensional，but line 是 one dimensional。OK。For example， 我们可以混着 intersect。For example， 我拿一个 line 跟一个 plane，OK， 拿一个 line 跟一个 plane，一呢，这个 line 可能活在这个 plane 上面 ，intersect 又是 line 自己了。But 如果它是 non-trivial 的 intersection 呢，它只有一个点。So you see the intersection is dimensional low than what you started with. Okay 吗？Okay. So when you intersect this surface with a plane, you get a curve. And then this curve, you can talk about gradient already. So what's this gradient here? This is the Fy, Fx you computed just now. So let's test this theory. Let's test it. So let's compute this. Let's test this. Okay, compute this too. 哎，算过了吗？还没有算过。Okay, let's compute this too. And we will see how to see this gradient. Try compute this. I think it's quite quick. Okay, I give you 1 minute. Try and compute this. So this is just a polynomial, right? So what is fxy? 能算到吗？ What is fxy? So keep y constant and then differentiate with respect to x. Right? Hello, 建彤会算吗？有答案。Okay. How about with respect to y? -2? Yeah, with respect to y. Good. Okay. So how about if you evaluate at the point 1, 1? -2 and -4. Okay, so from this picture, how do you expect this gradient to happen? So you look for the 1, 1 in your domain. Okay, look for 1, 1 in your domain. Okay, look for 1, 1 in your domain. Let's draw it. Look for 1, 1 here. Okay, let's say this is 1, this is 1. Above 1, 1 here, what happened? There are two gradients, right? One is -2, one is -4. Okay. -2 is in what direction? In the x direction. Okay, so let's draw our graph. Where our graph live. So our graph looks like this. So in the z direction, in the x direction here, there's a gradient which is -2. -2 is what direction? -2 is like this, right? Okay, because positive is the other way around. Okay, so there's a gradient on the top here. So there's a gradient at the top here. -2. Okay, above this point in the x direction. But in the y direction, the gradient is what? -4. So -4, you want to pick First curve or second curve? Huh? First curve or second curve? E has a negative gradient. Oh, right. Okay, because this one is y equals to x. Okay, in general, y equals to positive k times x. Okay, the other one is y equals to kx, where k is less than 0. Okay, so you need to put the other direction. So maybe let's use the other color here. You have negative 4 in this direction. Okay, so the first one, gradient is -2, and then the other one gradient is -4. Okay，可以开始想象了吗？这个图片。So in the y direction, it flows downward when you go in y direction. If you go in x direction, it also fall downward. OK，所以是一个从这边往下来的一个东西，这个蛇皮。太平兄有问题了，解释一下。整个东西啊，也我们就在 x 的时候，哪一个啊？在 x 是什么意思？这样，不是，不用紧，你就用你的理解。我觉得你有理解错误，我觉得。Because x is a direction, it's not just a point, it's a direction. So meaning going this direction here, the gradient is from top to bottom. When you go in the direction of x, if we consider the direction of x, okay, you are going from top to bottom. Similarly, on the y direction, if you go in the y direction, the gradient is also negative, so meaning also top to bottom. So the basic shape you need to memorize in your mind, which is y equals to kx, or y equals to something x. Okay, this basic shape you need to remember in your mind. Okay. So 如果我们真的去拿 GeoGebra 去 prove 它 you really see that the surface is going from top to bottom in two directions. Okay, x and y. So let's see which one is referring to x, which one is referring to y. What do you think? C1 is referring to x or y? Which direction? C1 这条线，这个 tangent line, x or y direction? X, right? Because 你看它是往着 x 变化的。Okay, you use the zx plane to intersect it. And then C2 will be y direction. Yeah. So this is the meaning of fx and fy. It tells you along 这条线，这条 x 的方向我是怎么变化。Okay, along 这条 y 的方向我是怎么变化。只有两个方向罢了哦。但是我们之前讨论 limit 的时候，不是要讲周围呢？ But now we only talk about fx and fy. Okay, somehow these two is already enough to tell us everything we wanted to know later. Okay, so it's very important, fx, fy. 这个东西就有点像 basis 的。Okay, 为什么 vector space 是 infinite set， 但是只要用两个 basis 做的。Okay, this is a similar idea there. We are going to use fx and fy to talk about differentiability around that later. Okay. Yeah. So this two is kind of like a basis in a vector space. What time is it? Okay, maybe we do one more and then we take a break from there. Let's do one more. So Okay, try and find this using implicit differentiation. Did you learn implicit differentiation anywhere on? 有学过吗 ？implicit differentiation 哪里啊？热酸啊，除了它热酸，同学啊，对，应该在其他课应该会看到 ODE 有没有？ODE 什么地方看到？什么名？theorem 吗？还是什么？theorem？OK，有人记得吗？什么 theorem ODE 啊？然后大声一点啊，听不到，可以。英文呢？ODE，你刚才说什么？差分方法替换。你们没有学英文的咩？你们都是学中文的咩？在这边多一个英文字我都听不到。阿拉是用华语教的嘛？OK，and then exact 哦，exact solution 是吗？还是啊？OK OK，呀，那个是蛮重要的 theorem 呀，那个其实是 exact 的。OK，so how to do this? Okay, so how to use this? What does it mean by implicit differentiation here? Wait, let me see how do I introduce to you. Well, later we will see. Later we'll see implicit function again. 还是我们现在不要做先？还是要做先？要做还是不要做？Later I'll introduce this more rigorously. How about I teach you the technique first? Teach you the technique first. How to compute this. So let's say we want to let's say what we want to do. Want to find this del z del x. Okay, let's say we want to find this del z del x. So what do we do here? 要这种东西很假的，要讲出来。Okay, anyway, we just learn technique first. I make a disclaimer here. Let's learn the technique. Later, we will mention about this theorem properly. But now we just learn this technique. Okay, so how to compute dz over dx? So the idea here was, so when you come out the equation, if you see, look at this equation here, right? There are how many variables? Okay, so there are three variables here. So when people ask you, find dz over dx or dz over dy means what? This z variable should depend on x and depend on y. But is this the case or not? 啊？为什么？为什么不知道？What's the worry point here? In point here. Whenever we say z depend on x，在中学有没有每次问一个问题是说，please express x in terms of variable of y, for example, or express y in terms of x. But can you do it here or not? Can you express z in terms of x and y? 有一点难。Right, you cannot. Why 啊？为什么不能？问题出现在哪里？What's the problem here? I can move. I mean, you can play around with this equation here. You can do like this, right? But can you move the other xy across? 做到吗 做不到不是不能 differentiate 啊。So that's why we have this rule here, implicit differentiation. Although we cannot write z in terms of some function here, we can just differentiate both sides, okay, with the same variable. Okay, so this is what we meant by implicit differentiation. Okay, it's implicit. So if I write like this, how should I understand this? So you should understand that, understand what? These x, y, z are all different variables. Okay, different, I mean, there are three directional in this case. But, but one thing to note here is z is not an independent variable here. We want to describe z in terms of x, y. Okay, so z is a dependent variable. So that's why when we start this course, we mentioned about what is independent, what is dependent. So we somehow still want this z is dependent on of x, y. Is this true or not? Is this true? So what does it mean by z dependent on x, y? Meaning what? You give me x, you give me y, pretty much z is already confirmed. So this is what it means by dependent. So you give me x, give me y, you will find z already. 对吗？如果你给我 x 给我 y 的，我是不是可以找到 z 啊？其实。So this is not just about z You can also talk about y dependent on z and x, or x dependent on y and z. Y 为什么会有这种情况发生呢？Because there are three variables here. I give you an equation. So this equation already decreased one of the degree of freedom. Does that make sense? Okay, so that's why one of the variables should be dependent on the other. So you could imagine that I give you more equation, the degree of freedom will decrease more. In principle. Engine. Right. So if you do this, how do you differentiate? So you treat z as a function of x, y, okay, and then you treat x as x and then y as y. So what do you do here? So you get del x of e z squared times del z. Let me think. Correct. Del z over del x. Okay. So basically, I use some rule here, and then here I use chain rule. Okay. Does chain rule work for you? This case, 看得懂吗？这个 chain rule differentiate over dx of z cube is a chain rule here. 看得懂吗？ Okay. And then plus 6yz. Okay. On the other side, you get 0 minus 3x squared plus 0. And then, surprisingly, we can write del z over del x equals to what? Minus x squared plus 2yz over z squared plus 2xy. Okay, so you can see that actually this del z over del x not just depend on the x and y, you also have z contribution come into. The actual value also contribute to this. Yeah. 什么 ？Yeah. 看一下有算漏掉没？哦，对对对，Thank you. So what do we left here? 我还有什么东西算漏掉？Let me think. 我在做了什么？我把 s 丢掉，做 differentiate 了。OK，我还漏掉 differentiate step，所以我还有一个6xy del z over del x。 是这个吗？有算漏吗？看一下有没有东西算漏。So z is a very function of xy. So 6x, y, z, there's two functions in terms of x. So you need to do product rule. Okay? And then on the other side, only one of them has x. So the other two go to 0. Those treat as constant. OK,没问题吗？全部人有算到吗？这个呀，哪一个？可以，因为没有办法，改不了。就是表示不到啊。如果能够表示到，我们就不要做这个了，我们直接跟刚才 differentiate 就好，对不对？我就是表示不到啊，所以这个是情况是什么？So this what's this function here? Del z on xy is what? You need to substitute x and y, and then you also need to substitute xy into your z actually to get the actual gradient. Okay, so that's what I meant by the z will contribute to this gradient. 在本身的高度都会影响这个 gradient, not just the point in x1. Does it make sense? You see, this gradient on this xy need to take into consideration of zxy, not just xy itself. Just now, whatever we compute is just xy, right? Just domain point. But now you have contribution from your value at the xy itself. 它的高度你都会影响它的 gradient. But later we will see why this work. Later we will see. 我们等一下会用比较 general 的方法来介绍。OK，actually，这个东西很熟悉一下，你不觉得很熟悉吗？一大堆 variable 等于一个号码，把号码想成一个高度。Yes，这个 case 是 three variable 嘛，所以 it should be a level surface。OK，所以其实我们在做的 implicit differentiation 是什么东西？你要问。等一下我们还会看到这个东西，等一下我们会看到这个就是一个双法的，他们看到我们到底在做什么。Yeah， 有问题吗？OK。Later we will introduce this. Okay. So let's take a break until 10:20. Sorry, 12. 几点啊？11:20. Eh, 什么来着？Full scape 啊？不是有分呢？可以吧？可以。应该可以，但是那个 full scan 不要太大，就跟 A4 一样 size。耶耶，啊，那个线可能会 那线可能会拿掉你一些位置。没有了，开玩笑，开玩笑，开玩笑，开玩笑。今年你的 Project One 选题目，然后你要选什么？什么？应该是要想好的。对，怎么办？啊？今天啊？今天啊？今天你不要告诉我啊。对，assignment 怎么办？呃，这周交几个？交两个啊，交得出啊？哪两个？好，一和二，可以。三呢？三做到哪里了？啊，下是上个之前。哦，OK，不是，我说你现在有做到哪里吗？还是没有做？还没有做到，OK，不用紧，你跟我诚实讲就好，我不会骂你的。但是你要知道你怎样去处理这些事情比较重要。现在你不是小孩子啊，我不用拿着藤条天天追着你这种，你自己要搞定你自己的生活。我想一想啊，下一次上课是考试诶，拜二，你知道下个星期要考试吗？要记得来考试哦。还有一个很重要的东西我要跟你讲，可能你不知道。你知道如果 assignment 跟考试没有达到40%，就已经先 fail 了啊。所以如果你的 assignment 不交，不是你就少了很多个 percent。然后如果低于48线的话，就会fail，不用考最后一个考试你就已经 fail 了。OK，所以最简单不 fail 的方法就是你一定要把这些 assignment 做到。因为我们是花时间可以找资料的，只是不可以抄吧，你要去理解，然后用自己的语言写出来，OK 吗？然后要写下你的 reference 去哪里找的这些答案，懂什么意思吗？就是说你参考这个人的答案，参考啊，不是抄啊，参考。然后其实这堂课没有这么容易 fail，因为我们有很多 assignment 跟 project，如果你不要 fail 的话是有可能的，OK。然后还有什么要跟你说的？对，Project One、Project Two 其实是很容易得分的一个作业来的，因为 basically 就是你找资料，把东西拼在一起，就是你的 project 了。哦，可能考试会比较难一点，但是这些 project assignment 呢，你应该要得分，因为是有时间给你做的，做得好不好是另外一回事，你知道吗？但问题是有做就有基本的分，当然是不要写错的答案了，就是差不多对的答案。OK。那个 project 题目一定要给我啊，里面，OK，你要跟我讨论哦，其实适合吗？做，就是你觉得你可以做，你要问我，然后我答应了过后，你才可以继续做，不然的话，可能你会不达标那个 project。嗯，
问你一下，
嗯，
你的那个 draft 是要什么深度？因为我是用蓝带先打出来，现在
也是可以啊。其实那个 draft 啊，不，可以啊，可以啊，没问题。
我们定发给你是用那个 Gmail
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 不怎么可能用 Gmail，就用学校 email 吧，最多
哦，学校 email，
啊，学校 email 或者 Teams。
我直接打出来，我直接发给他。
可以，可以。 哎，取消我啊？什么？啊，对，就是有那个问题，但是我们还可以做 differentiation。现在问题是没有错。Yeah, this is what we call a multiple value function。它会有就很像 simple K，就是我开始跟你们讲的那个蛇根 x square 加 y square 的。如果要变成 function 的话，我们肯定要拆成上 top 下面这个跟 bottom 下面是。对对对，那个 theory 是应该是说我们要怎么把它理解成一个 function，然后我们再做 differentiation。但是 somehow 这个 method 我算出来的东西一样。之后我们会提到具体你要怎么做这个。Yeah, exactly，就是 is a multi-value function here. The multi-value function。其实，I mean，这边 differentiate 的话是不对，I mean 方法的，but somehow in this case we still can do this because there's theorem say that you can do this。哎，做得到，你只是把这个 function 拆成不同的套，就像那个蛇格的形式，你还记得吗？变成什么 plus minus square root 啊什么之类的。Obviously, yes, yes, yes，一定要做得到啊，不然我讲 differentiate，一定要做得到。但是那个 form 怎么找就有一点 tricky，dependent form 怎样找很 tricky，其实会很复杂。如果 I mean for circle 的 case 很简单嘛，就 plus minus square root。啊，这个呢？如果把 z 丢掉，可能不行，就 cube root but 所以不止 cube root，这个东西好像要 involve complex。I mean depend on 你讲好的话，可能不用啊，可能不用 complex。来要吧，要不用，其实对，我们活在 real 里面。其实这些问题是很好的，虽然在这个课不会遇到他们，但是它会帮助你去想，怎么我们做这样的计算。等你以后进到比较难的课的时候，这些 idea 就会 come smoothly 进来了。But at the moment, you just learn this implicit differentiation. Okay, so you have an equation. Just go and do your partial derivative on both sides. Okay, so this is the basic thing you need to learn. Okay, so 在这课里面呢，我们会教 basic 的东西，我们也会想一些 advanced 的东西。所以希望你不要 confuse 这两边。
如果你想不通那 advanced 东西，你还可以把它丢掉，至少你要先把 basic 东西解决，不要因为 advanced 东西进来过后，你觉得 basic 那个你也搞不懂。说你们的脑袋里面要区分一下这两件事情啊。有时候我会混着讲，所以你就要问我，有时候。OK OK to motivate next example next theorem let's compute some derivative first. Okay. Let's compute some derivative first to motivate the next theorem. Wait here. Okay. So let's compute this example. So where is the example? So let T be Z e to the W square plus Z square plus Y square. Okay. So now there's a job for you. Try and find just find 里面 exercise 里面 exercise 有找其他东西，你可以 try and 找。But 现在我只要 discuss 这两个先，我也会放答案进去，你不用怕。所以我们现在只是找这两个 ，focus on searching these two item here. Try and find this. 哎，我只教你 differentiate 一次哦，所以会不会 differentiate 第二次啊？对吗？As long as you know that del t over del, for example, for the first one, if you know that del t over del x is in terms of w, then you can do partial derivative again. 这俄罗斯套娃，如果还是那只俄罗斯蛙，你就套进去吧。如果不是俄罗斯蛙，可能是意大利蛙，你就会乱套。OK，如果还是俄罗斯蛙，你就 Yeah, let's do first. Let you experience first. Later we'll discuss together. 有没有 x 啊？没有 x 跑去哪里啊？你看我闪光，把 x 看到 z 啊，确实这样就不好玩了，太小里面的字，闪光了看不到，z 跟 x 是分不开。嗯，z 一是不是 s 一啊？z 一不是 s 一，z 一是真的 z 一。所以这里面有4个东西，其实还有一个，它还有一个要你算的是这个，但是现在不是很重要了。你要算也可以吧，我们不要讨论，就讨论前两个先，前两个比较重要。来算一下这两个是什么东西。then 还有一个，哦，难怪，喂，还有个 notation。So are you guys confused when you see this notation here? Actually, this notation comes with order. It comes with order. So the order is how you read the denominator order. So if it's closer, the one that's closer to t, you will do it first. 这是应该要 define 的。找一个 definition. So the order here is important. 所以 del x 跟 del w 不一定一。del x, del w and del w, del x 不一定一样。Okay, so the order is important. Right. OK，全部人有算到东西吗？What do you get for the first one? Maybe I ask the left hand side here. Do you get del square t over del w del x? What's the answer you get? Left hand side here. And maybe we get another solution from right hand side. Del square t over del x del w. 有算到吗？ 4xwz e to the w square plus x square plus y square. On the other side, this side 有算到吗？这一边的人。What is del square t del w del x？ 算到吗？什么？4xzw e power w square plus x square plus y square. So did you notice that these two numbers actually the same? 其实是一样。This is not a coincidence. This is not a coincidence. This is Claira's theorem. Okay, so if both fxy, fyz are continuous, then they are equal. So on continuous where? On an open set. So what does this open set define? So you can really take this open set as open this. Okay. Open this. Still remember the open this I drew to you last time? 慧琪还记得吗？什么叫 open this？ 啊，找一找。什么？好像是诶，上课有提到。呀，找一下。什么？啊，是什么？是什么？我没有听到是什么？中间有个洞，那个是真的 this 啊，但是这里的 this 没有动。放进 DVD player 的要有洞，但是这个没有洞。这个就是一个圆圈，然后我拿完里面的点。OK， 一个圆圈我拿完里面的点，但是我不拿它的周围，它的 boundary。I don't take the boundary point. Okay, I just take everything inside the circle. OK 吗 ？OK, so why is it open? Open interval. 你的脑应该要想一个 open interval. Lower dimension 我们全部可以从 lower generate 上来。所以 open interval 是什么 ？You get rid of the endpoint. But 这个 this 的 endpoint 在哪里？就是它的 point that has radius, let's say d in this case. Okay, so whenever we talk about open this, sorry, you need to tell me what's the radius. Okay, so of radius, let's say delta. Okay, so the point live in radius delta, I don't take. Okay, 我不拿。Okay, 是最边缘的点，我不拿。Okay, the boundary point. 有问题吗 ？Okay. Okay, so whenever we talk about open set, you can think about open this. It's enough already for your course. Okay, 已经够了。讲 open this 就好。Open set is a more general thing. Okay, 可能 union of open this 还是 open set， 一大堆的 open this 在一起。But for your course, you just think about open this. It's very good already. Okay, so this is Claire's theorem. So Claire's theorem tells you that even if you swap the order of partial derivative, they are still the same solution. When is it? When both of them are continuous. Okay, on an open this. Okay, so I show you the example also. Right, so obviously you can extend the definition of partial derivative to n variable, 3 variable, 4 variable, 5 variable, 6 variable. Okay, so meaning if you want to partial differentiate with respect to x, you just keep all the other variable fixed. Okay, it's the same story. Okay, so you can extend it. And then the higher order partial derivative here is we call the mixed partial derivative. The mixed partial derivative. Let's keep this. Okay, we compute this. And then Do you have this in your ODE? Maybe no, this is like PD. Similar thing. So if you want to show this function satisfy this Laplace equation, what do you do? 什么意思啊? What this question asking? What this question asking? First of all, they define a function, okay? And then this is a verb is what? Is a solution to this equation. So 这句话在讲什么东西? So, okay. One thing you need to take note when you read these mathematical statement, you need to know what is the nouns, what is the verb. Okay, so what are the nouns and verb here? So first, there's some function. What is this function? This function is a solution. Solution to what? Solution to a Laplace equation. Okay. 意思说什么？啊，金色。OK， 这句话的意思是什么？想检查这句话。想检查这句话。比如说一个 example 比如说一个 example， 给你一个 example， 你是会的，只是你可能没有想到吧。Let's say 1, 2 is the solution 2x minus 2 equals to 2x minus y equals 0。想检查这句话。下面对，做 differential on 谁？好像我把它画到了，把它画小一点。哪一个 function？ 啊？ Correct. So we need to check that whether del square of ex sine y over del x square plus del square of ex sine y over del y square is equals to 0. Okay? Okay 吗？需要一起算吗？还是自己可以算？自己可以算 Okay, good. So does it mean that this is the only solution or not? Does it mean that this is the only solution? You just prove that one solution works. For example, in this case, right, is this the only solution? Is 1, 2 the only solution? What other solution you get? Huh? 0, 0 哈 very good， 很好，这个 0, 0点很重要。其实还有什么点？2, 4， 还有吗？还要讲一个点吗？3, 6，把这些点 satisfy 什么 property？ y equals to 2x。 y equals to 2x 是什么？一条线，整条线都是它的答案。为什么有这个 origin？ 因为这条线 pass by the origin。这东西不是你在linear algebra学的吗？这是个 null space。null space is a line。OK 吗 ？Yeah。有 free variable。OK。Yeah。This is your null space。对吗？你是不是 null space？ 这个东西变成system of linear equation 是什么？1 2减1 0，对吧 ？What's the row reduced echelon form 这个 ？At most one pivot position. Then the next variable must be a free variable. So that free variable will form this line here. Okay, yeah, linear algebra 也是要画出来的，不画出来就一大堆 matrix 那边搬来搬去，不知道在做。 OK，你要画出来，全部都可以画出来。So let's continue. Okay, now here come to a very very challenging concept here. Right, so let's start. OK，请大家专心一点啊，这个 part，因为这个 part 蛮 challenging 的 concept。So it's a tangent plane. So what's tangent plane here? Suppose that f has a continuous partial derivative. So 你就用你的 del f del x del f del y. Okay, they are continuous. OK，我们加了 continuous 吧，对不对？你要 check 那三个条件。So if they are continuous, then we can define what's called a tangent plane. We define it. So what's the tangent plane here? This plane is an equation such that z minus z naught is equal to fx of x naught y naught times x minus x naught plus fy x naught y naught times y minus y naught. Hey, let me ask you a question first. Do you still remember what the plane equation is? What's the general plane equation? Dot product. I mean, after dot product, you got the formula, right? So let's write down a general equation for a plane. What's the general equation of a plane? Maybe containing x naught, y naught, z naught. Should be a coefficient times x minus x naught plus a coefficient times y minus y naught plus c z minus z equals to 0 for some a, b, c in real number. 对吗？是这个吗？ Yeah, sure. This formula is coming from the dot product derivation. Okay, but I want to get this formula here. But can you compare these two? What's the difference here? I kind of fix what is ABC here. What is ABC here in the tangent plane? A is what? Yeah. A is what? 看这边就好。A is what? A is what? 什么东西在 S 减 S 0旁边 ？In tangent plane. A is what? A 是在 x 减 x 0的旁边，所以谁在 x 减 x 0旁边？啊 ，sorry， 听不到。啊，听不出来那个听不出。x 减 x 0旁边这种东西。partial derivative of f at with respect to x. Okay. B partial derivative with respect to y. C 是什么？康波。D 是什么 ？E 还是减 E？ E 还是减 E？ 减 E, right? Okay, because you move to the other side. So meaning what? This tangent plane is a specific plane with the coefficient built up by the partial derivative. 是吗？是不是号码来的 ？f x x not y not 是不是已经是 real number 了？为什么是 ？Why is it a real number? Because we already evaluate at the point x not y not. So where do we get this x not y not from? 从哪里来的这个 x not y not？ 从哪里来的？这 x not y not？ 啊 ？Point P good P 是什么点？我们要看。This is the point that we want to find the tangent plane. Okay, this is the point we want to find the tangent plane here. Okay, so x not y not here actually correspond to the point S0, Y0 in your domain here. Okay. Okay, so this is a tangent. Hey, by the way, let me ask you a side question 啊，你会觉得这个东西很容易背吗？背得起来吗？这个东西怎样背啊？ You should use generalization. Plane 是什么的 generalization? Straight line. Straight line 的 equation 是什么 ？ax plus by equals to c。所以什么差别在这边？这个差别是加多一个 linear variable. Let's just add one more linear variable. But why we have this shifting? This shifting is just you shift the plane or shift the line. Okay. And then you will learn in linear algebra that actually this is a generalization from dot product. Okay, how you describe the point on plane. But we won't go into it here. Okay, so let's do exercise first. So try and find equation of tangent plane to this specific surface. Okay, try to do this. I give you 2 minutes. So what's the thing you need to find? So basically 2 ingredient, right? You need to find fx at where 1, 1 in this case, and fy at 1, 1 in this case. Okay, so what are these 2 ingredients? So to decide a plane, you just need to tell me the coefficient. So you need to compute this coefficient. Okay. So let's give me what is fx first before evaluating. What do you get? Let's check answer. If you differentiate with respect to x, what do you get? 哎，不要看，念出来。念。Yeah, for x good. With respect to y, to y. Okay, so after you evaluate, what do you get? Fx 1, 1 equals to 4. Fy 1, 1 equals to 2. Alright, huh? Yeah. Right. So what's the tangent plane formula here? The tangent plane formula was you have your coefficient for z minus z not as 1 equals to fx. Okay, so you substitute all your point into it. So what's your x naught, y naught, z naught in this case? So let x naught, y naught, z naught to be 1, 1. What's the point? 1, 1, 3. 1, 1, 3. Okay, so in total you get z minus 3 equals to 4 times x minus 1 plus 2 times y minus 1. Okay, right, to remind you about your dot product concept, right? Actually, you said that this vector here, 4, 2, minus 1, is a normal vector to the plane. Okay, so a normal vector to the plane. Okay, if you use the dot product method to see this plane. 对吗？什么是 normal vector 啊？ This is a vector that is perpendicular to your plane. Okay, so to talk about a plane, you just need to give me a normal vector and a point on this plane. 对吗？你想想看，是不是如果活在这个 plane 上面的每个点、每个 vector
一定要90度为这个 normal vector。如果不90度会发生什么事情？想过吗？想过吗？如果不90度会发生什么事情？那个 vector 不是就会either跑上来或者跑下去吗？对吧？either跑上来或者跑下去，跑上来就 curve up 哦，跑下去不是 curve 下去哦。Okay, then it's not a plane that you know about. Your plane should be linear, right? Okay. So you need to make sure it is 90 degree. So actually by definition, the plane is 90 degree to this normal vector. Okay, so to build a plane, you just need to tell me a normal vector and a point on this plane. Then you can actually span out the plane already. Does it make sense? Because if you give me another point, let's say you give me another point on this normal vector, then this will span out another plane, which is a different plane already. Okay, although they have the same normal vector, but they are different plane. Okay. 有问题吗？上面 OK Yeah. 哦，这个是 by definition 吧，这是 define。等一下我会let me see Later we will tell you why this definition useful. This is definition, so this is by definition. This is definition. And then later we'll tell you how we use this tangent plane. 为什么它值得这个名字 tangent plane? Later we'll tell you. For now, 我只告诉你这个东西叫做 tangent plane. 等一下会告诉你为什么它真的好像 look like a tangent line. OK OK 吗 ？Yeah. 现在只是告诉你有一个这样的 plane。等一下我们会证明给你看这个 plane 真的有在做 tangent， 我们想 tangent plane 做的东西。OK，does it make sense？ 现在我只是 define 一样东西给你看，我们给它一个名字。OK， 还不知道它是不是有很好的用处。But later I'll show you 它有什么用处。OK，so the idea of tangent plane was if you look at this surface here, and then you build out a plane at 113，这个是你刚才算的东西，看一下是不是？ Yeah, I think so. Yeah, this is what you computed just now. But if you zoom in and in, if you zoom in and in, actually near the point, the surface is almost looks like the tangent plane. This concept actually you can see from calculus 1 already. For example, similarly, do the x squared. Okay, and then you draw a tangent line like this. If you try and zoom in this point, it's almost the linear line already. Although globally you'll see that it's curved, but locally it is straight. Straight line. Okay. 就像你站在这个教室上也是这样。If you look from the viewpoint outside the Earth, you'll see that this Earth is a sphere. But if you just stand on here locally, 课是做到很平没有这样斜下去嘛，对不对？平的。Okay. So locally is a plane. 如果你放的足够大的。Okay. Even if it's not, we are still approximating it. 很靠近啊，你放的越大，它就越靠近这个就越像这个。Okay, if you zoom in enough locally, you'll see that around you is just a plane. Okay. But there's a condition. There's a condition. Only if your function is differentiable, you can see this. If it's not, then it's useless. Next time we'll talk more about it. Okay, any questions so far? This is what we want tangent plane to behave. Okay. 有问题吗？ So basically the idea was 我们把一个很不规则的图案 geometry, we use some standard linear function to approximate it. OK 了，linear 的比较容易控制嘛，但是如果你可以想象很夸张的 function 出来 ，then 你就不好控制哦，每一个点的变化。Okay, but around the point, around the point, yeah, around the point is just, okay. For example, in one variable, maybe just a line. So line 跟 plane 的共同点在哪里？ They are linear. We only use power 1 to define it. I don't know. Using x, y, or z. They are linear. Okay, so next concept we will talk about linearization. 把它变成 linear 的东西。OK， 把它一个 surface 我们放大的时候，它其实就是这个。Okay, so these are easy cases we will look at. Any question? I think we should stop here. So when's revision class? Where is it? A4G06. Okay, so see you in 1 hour. 很赶哦。